Okay, so we're going to do another one, which is balancing redox reactions in a basic solution. So for a basic solution, we have one extra step. Obviously, we have OHs instead of H's, but we're going to pretend we're going to use the H's first. So we're going to do all the steps that you do the same for acids, including adding H's to each side. Then however many H's you added, you're going to add the same number of OHs. All right, we're going to start balancing this redox reaction that is in a basic solution by finding the oxidation numbers. Oxygen is -2. There are 3 of them. That's a total of -6. We have to leave a -1 charge on here, which means iodine has to be, iodine has to be +5. Oxygen on this guy is -2. There are 8 of them, or 4 of them. That's a total of -8. I need a -2 charge, which means my carbon total has to be +6, so it will be +3. Iodine is -1. Oxygen is -2 here. There are 2 of them. That's -4. Oops, -4. And that means this carbon has to be +4. So if you look here, you're only going to pay attention to the things that change their oxidation number. Oxygen is -2 in every case here, so it's not involved in the redox reaction part. But iodine goes from +5 to -1. So let's look at that. So from +5 to -1, we have gain, that's a gain of 6 electrons total for every iodine atom. Carbon went from +3 to +4. That's a loss of 1 electron for every carbon. But we're dealing with 2 carbons. So we're talking about 2 electrons being transferred totally. Okay, so we've got that kind of squared away. So our next step is to balance the number of electrons that were moved. If 6 electrons got moved on this equation, but only 2 electrons moved here, I need to multiply this equation by 3. So I'll put a 3 here. There's already a 2 there, so I will make this a 6. Okay, so this is my reaction that's balanced. So let me double check my carbons. I have 6 carbons and 6 carbons. Okay, good. Are my electrons balanced? Now I have 6 electrons transferring and 6 electrons transferring. Yes, so my electrons are good. The only thing I have left to balance is my oxygens. So on my reactant side, I have 3 oxygens, and then here is 3 times 4, that's 12, so 13, 14, 15 oxygens to deal with on this side. And I have a total over here of 12 oxygens. So it looks like I'm short 3 oxygens. So I'm going to add 3 waters to this side so that my oxygen atoms can remain. This example, by the way, is on page 612. You need to walk it through again. So I've got my 3 waters, and now I've added H's. So I'm going to go ahead on this side and add 6 H's to my equation because I've put 6 H's in. But so now my H's are good and my O's are good. The problem is I've added H pluses and I'm really dealing with a basic solution. So the way that you do that, the way that you fix that is at this point, after you've added H's, you are going to add the same number of OHs as H's that you added. So I added 6 H's. I'm going to add 6 OHs over here on the reactant side or the product side. And I'm going to add 6 OHs over here. So now 6 OHs plus 6 H's gives me 6 waters, 6 H2Os. Because the 6 OHs that I added and the 6 H's that I added combined to make 6 waters. That means I've got 6 waters over here and 3 waters over here. I want to reduce that, so I'll cancel those out and leave 3 over here. And then I have my final answer, 3 waters plus iodate plus 3 C2O4 minus will yield I minus plus 6 carbon dioxides plus 6 OHs. Notice the H's have been canceled out. There's no hydrogen ions. There's just hydroxide ions, and that's good because you're in a base. Okay, so this is one extra step if you have a basic solution. So pause this and try a couple of examples. Okay, the next half is going to be, hopefully you've practiced a couple of those. The next way that I'm going to teach you is how to use half reactions to balance redox reactions. You're going to do the exact same thing. In fact, you're going to start with oxidation numbers. Then you're going to actually pull out the half reactions into 2 separate equations. You're going to balance each of those oxidation and reaction equations separately, and then you're just going to put them back together. And once they're back together, you will have your final balanced equation. Okay, so let's give that a go. We're going to do the same reaction that we used earlier, but this time we're going to use the half reaction method. So we start again by doing the oxidation numbers. Oxygen is -2. There are 4 of them. That's a -8. This has to be +7 because I have a -1 charge. Iron's +2, Mn is +2, and iron is +3. Let's figure out, so Mn went from +7 to +2. I'm going to write that out as one of my half reactions. MnO4 minus 1 minus goes to Mn, Mn2 plus. Now, this is going from +7 to +2, so it's it's gotten less positive, therefore it's gained some electrons. It's gained 5 electrons. So we should write those 5 electrons in, okay? That is my gain electrons is a reduction GR, so this is my reduction half reaction. Okay, now I'm going to do my iron half reaction. So iron went from +2 to +3, got more positive. That means it lost an electron, and that electron is over there. Now, here are my 2 half reactions. There's my oxidation one, and there's my reduction one. And notice this one is an electron transfer of 5, and this one's an electron transfer of 1. So I have to multiply these 2 reactions by some coefficient so that their electrons transferred balance. So I'll multiply this top one by 1 and this bottom one by 5. Okay, so that's that. Now let's have a look at my iron equation. I got 5 irons, and 5 electrons balanced for charge. This one's done. We're good here. My magnesium, my reduction reaction, has 4 oxygens that I don't like sitting there. Move this guy out of my way because I'm going to write on him. Okay, so I'm going to have to add to this 4 waters so that I can balance my oxygen here. Because I've added 4 waters, I've added H hydrogens on my reactant side. This is an acidic solution. I can't have my hydrogens not be balanced, so I will need to add 8 hydrogens on that side. Now I'm balanced for hydrogens, I'm balanced for oxygens, I'm balanced for electrons, I'm balanced for everything. I'm going to put these 2 things together. I'm going to add them together. Anything that appears on the reactant side of one and the product side of the other can be canceled out. So my electrons should be canceled out. This was just my coefficient timesing it by 5. So I'm left with 8 H's here, 5 Fe 2 plus, and MnO4 minus. This, and this. Good. And then over here, I have this, and this left. Mn2 plus 4 H2O plus 5 Fe 3 plus. And you can check the other example. This is the same half reaction. Same thing, if you had a base, you wouldn't stop at the adding 8 H's. You would then add 8 OH's to each side and gather them up, make water, cancel the water out. I'm just going to scratch that out because we're not doing that in this example. But again, there's some examples in your textbook for that. So that's 9.2, the half reaction method. So again, give that a shot. I don't care which way you use. If you use the half reaction method or if you use the oxidation method, you may do on the test either way. But you do have to know the difference between balancing in an acid and balancing in a base. So please try some of those practice questions, try the worksheets, and good luck.